process, the movement of duty and right. And the principle here is a pattern of the process.
So the formal specification on the right-hand side will be written in predicate logic.
Yeah, mainly in predicate logic. But
how about the operational model?
The operational model is the kind of implementation. This is in the prologue environment. The interprop is
Prologue you're going to use.
Right. But this is the platform on top of prologue that allows you to model the Petrinet, a special version of Petrinet that we call the documentary Petrinet, and also allow you to develop some kinds of reasoning. I mean, when you have the model, you can apply certain way to reasoning about the model based on the declarative rule specified in prologue. So this is the platform developed on top of prologue, and I will implement the method on this platform. I will extend the platform to implement the method.
So your research will involve these both branches.
Right. This is the two deliverables of the research. The thing I show here is the two deliverables of the research. All of them, remember, is about the first two stages of the research. It's not the whole redesign circle. The redesign circle includes four stages. So this is the first stage. You see, the modeling deontic process is about the first deliverable.
On the left-hand side.
Right.
Okay.
Right. Yeah. Right. And the second, the driving control requirement, is actually the right-hand side.
But there must be some correspondence.
Sure,
right?
they are strictly correspond. The thing is that I try to simplify the path here, but the control principle here need to get from the deontic process model.
Right.
Look at the
Seem to be
process.
shouldn't be two independent branches. This should be below that, right?
Sure.
Logically.
Sure. This chart is just simply like we have two deliverables. I don't say about the semantic dependency between the tasks.
Go back to slide number 9. I think you had slide number 9.
The previous one, right?
Nine.
That one.
No, this is a 9.
Right
Yeah,
here.
yeah.
This one.
Yes.
This gives them only.
Yes.
Yeah.
Yes.
Those are the same two boxes.
Yeah,
The
yeah.
same.
So now he spreads to two sides. So that's why I want to see correspondence.
Okay.
So
Yeah.
okay.
The thing the purpose, this means I just show there two.
So actually develop a deontic model first. Then you try to use deontic model to derive the control process.
Exactly. That is the first stage to model the deontic process. And that leads to the second stage, the driving control requirement.
But then that chapter is a little bit misleading, the next one. Because it seems to be doing two independent things. You try to combine them to get something.
So
The errors are a little confusing.
The one next one is
The
Right,
arrows are
the errors
different.
are
right.
Okay, that's good. That's good command. Yeah.
May I distinguish between
Yeah.
the flow of the modeling methodology? So a user would follow these 4 steps,
Right.
as opposed to his research approach, which is doing these two. He's going to do this and this. They're sort of doing his research.
Right.
It's not that he finishes one and does the other. Because they have to work together, so the research sort of interoperates.
Yeah. This one is
He's
not.
thinking like this.
So actually,
More like a
it's
parallel.
more precisely, I would say, probably you have a mapping from DPM to CRR. What you try to do is your research is
Sure.
on the mapping, right?
Sure. But for me, this is clearly stated here, so I don't want
Right,
to repeat that.
okay.
I just want to say there are two
Okay.
things I need to do.
No.
This thing.
Okay.
Respond more clearly.
Right. Professor Hay suggests that we have a direction from here to here, from the DPM to the CRR.
Respond to the word mapping.
Right. The mapping is like, for me, it should, in this
Do you agree
figure.
with the term mapping?
Actually, I don't agree much with the term mapping in exactly semantic. You see? But the thing here, right? But this figure is actually it's not a flowchart. It's not a flowchart. It's just an informal chart
Okay.
to show you that they
So
have
if
two
you don't
main
agree with the term
levers.
mapping, what?
The mapping is much more. The mapping is if you
So
map.
if it's not a mapping, what is it?
It's in the influence. Influence or something, or something like that. But
You'll clarify as you go forward.
Yeah, okay.
We'll come back to that.
Okay. So, written here, I have two deliverables. First one is about the deontic process model, and the second one is control requirement reasoning. How to validate? So, I will validate the method through...
Sorry, let's go back. Just that.
Okay.
Okay. Should that control requirement feed to both of them, or should those come back to the control requirement? It doesn't seem right.
If you allow,
Okay.
we'll come back to this point.
Okay.
He's got other
Okay.
slides that I think
Okay.
will help
Okay, yeah.
clarify.
Okay, the validation of the research. So I will validate the proposed method in 3 dimensions. The first one, I will compare the result of the method to all the methods that reasoning about control requirement. Reasoning about interorganizational control requirement is not a new area. There are a couple of research on that. One of them is the research by Rosenbaum in 1997, and there are some other research, but this is the most complete one. Rosenbaum reasoning about control requirement by look at the dependency between activity, what needs to be done first, what needs to be done second, and so on. Here I provide another different approach. I reasoning about control requirement based on the procedural semantics of the deontic relation. So I will show that the control requirement generated by the proposed method is more than the one that generated by Rosenbaum. The second one is relevant to practice. Then I will collect a number of real-world cases of fraud, especially in international trade, and show that the cases are violating some of the control requirements generated by the method. The third one, I will show that the requirement generated by the method is more than some of the well-known security documentary procedure, like the documentary credit procedure. Even though documentary credit procedure is considered as the most secure inter-organizational transaction procedure for international trade. However, there are some chance that can be defrauded. So the thing is, I will show here the method will generate more requirement than the documentary credit to express more kinds of fraud. The second kind of validation is to validate whether the method can be implemented in a computing environment. I will develop and implement an operational of the method in a computing environment in the block, as I said before. And the domain I use to validate is the international trade procedure. The reason is that international trade procedure is the complex procedure, probably the most complex interorganizational procedure. The second reason is that there is a lot of, this is a well-known domain, so I have a lot of literature I can learn from and also compare the method, the proposed method again, the previous method. This is the key issue. And the third one, I think also important, especially for me. Before I come here, I worked for a bank. I developed the computer software for bank. So one operation in bank is about the international trade. So the documentary credit, for instance, is the normal operation in international banking system.
Just a quick comment. The word computability is improper here. Okay, so in computer science it means whether a method is computable or not. Like, you know, whether it can be effectively computed, like a first order logic is undecidable, things like that. So
In polynomial time. That's
not even in polynomial time, it's incomputable, undecidable.
No, but I mean,
Yeah, what he tried to do is
computability within
realizability. Use the word. Okay, so that means you want to implement whether you can implement. It's not
maybe would you be okay if he said the implementability?
that's fine.
Because realizability.
Yeah.
will-
Right. That's
Sure, yeah, implementability is
Confused
fine.
business.
Yeah, but computability means something completely different.
Right, that's good. What I want to do here is that to test whether the formal specification of the methods can work properly in a computing environment. Can work properly in a computing environment. So I will change to the implementability.